If your computer has multiple network interfaces, how you can know which interface the operating system will choose for your network traffic, and if the system chooses the one you don't want, how you can change the system's behavior to set the priority of your network interfaces. In fact, this is not a rare scenario at all, because nowadays for most computers, it's very possible it has already two built-in ways to access network. First, RJ45, second, Wi-Fi. So in this video, let's use a Mac, Windows 11, and a Debian 12 Linux as examples to explore the options. This is my lab environment. I have 3 computers in this video. They are all connecting to one unified gateway using Ethernet cable through their RJ45 ports. At the same time, they all have Wi-Fi cards. So they connect to an access point. That access point is connected with another unified gateway. So basically, from internet access perspective, each computer has 2 different ways to access internet, either through the wired RJ45 port or from the wireless, the Wi-Fi way, right? Let's first discuss how you can even know what's the current existing priorities for your network interfaces. Let's start with the Mac. Let me launch a browser. Then let me simply visit google.com. Okay, let's go back to the diagram, because now I am checking the SSL inspection functionality offered by the ubiquitous EFG gateway. If the computer is accessing google.com using the Wi-Fi, I should see the custom ubiquitous certificate from the browser. So let's see whether that's the case. Click on this lock button. Let me click on the show certificates. Then you can see this certificate is issued by WE2, not by Ubiquiti, which means now this Mac is not accessing internet through EFG. Instead, it's through the wired connection using the UDM Pro. So which means currently for this macOS, the wired connection has the priority. Then if I go to the Windows machine, let me go to the command line, then simply run route print. Okay, you can see for the 2 default routes, the first one I can tell from the IP address is for the wired connection connected to UDM Pro, and it has metric 25. For the second default route, from the IP address I can tell is the gateway IP address for EFG. It has 30 metrics. Because 25 is less than 30, the first one has the priority, which means the wired connection has priority. Then for the Debian Linux, let me launch a terminal. Then let me simply run traceroute. Let's say traceroute Google. Okay, I can tell from the very first hop, it's jumped to this IP address. This is the UDM Pro's gateway IP address. So again, for the Debian Linux, by default, it takes the wired connection as the priority. Based on the simple findings, we can see by default, all the 3 computers use the wired connection as the priority. It may be exactly what you want, right? But what if, for whatever reason, you want to change it? For example, in this video, we are using Wi-Fi and wireless, right? But maybe for your situation is you have 2 connections with different speeds, but the system prefers the slow speed one. How you can change that? And in my case, I do want them to use the Wi-Fi connection as the priority, because now for network texting purpose, I prefer so. So then let's go to the second part of the video for the 3 different operating systems, how we can set the network interfaces priority. Among the 3 operating systems, macOS is the one where this type of change is most user-friendly and most convenient. So I simply go to Settings, Network, see these 3 dots drop down, click on it, then I choose Set Service Order. See, it lists the priority already. You can see now Ethernet has higher priority than Wi-Fi, right? So then I simply drag Ethernet to make it below Wi-Fi. That's it. After I click OK, the Wi-Fi should have higher priority. Okay, that's how easy it is. close it. Then let me launch the browser to visit Google again. Then I click on the lock button, show certificate. Now you can see the certificate is issued by Ubiquiti, Unified SSL Certificate Authority. That confirms, yes, now the traffic is through the AP, through the EFG. We successfully changed the priority of the two interfaces, right? Then go to the Windows. To change in Windows, it's not very direct, but as long as you understand what it is really changing, it's very apparent, and you will understand why it's seemingly so indirect. You will know what I mean. Let me right click on the right side, the network and internet settings. Then go to the end, advanced network setting. Then it lists all the devices currently in my system, right? I'm interested in the first two, Ethernet and this Wi-Fi. Let me start with Ethernet. Click on this drop down. Then there's a button, edit. It added the more adapter options. Okay, then it will show you a familiar dialog if you once used previous older version of Windows. Find the IPv4 setting, then click on the advanced button. See here, there's a setting, it's called automatic metric. Remember previously when I show you the routing table, it has metric values, right? It comes from here. So by default, each interface has the automatic metrics. So if I disable the automatic, I need to give it a value, right? Then because this is the Ethernet, I don't want it to be the highest priority one. So let me say 100. Okay, then we are done with the Ethernet setting. Then set the Wi-Fi in the same way, expand the Wi-Fi, then click the edit, then change the IPv4 setting, click on advanced, disable automatic metric, and because I want the Wi-Fi to have the highest priority, so I simply say 1. So as long as the values are relatively lower, it will have the higher priority. Okay. Now we are done. Let me go to the command line, then run the same previous route command, route print. See, for some reason the system changed the metric value I set, but it doesn't matter because it does keep the relative value. So now you can see for the Wi-Fi, it has smaller number, right? And the Ethernet has bigger number. We can confirm by default, the system will take this default route, which means the traffic will go through the Wi-Fi instead. In the same way, we can run trace route. Oh, in Windows, the command is trace RT, slightly different than Linux. Okay, trace RT, Google. Okay, yeah, you can see the first hop is through the Wi-Fi, through the EFG. Perfect, that's exactly what I want. So because it's so slow, let me kill it. So we just confirmed we successfully changed the priority by setting the network interface metric. Then move on to Linux. So for Linux, there are multiple ways to achieve the same effect. But in this video, let me show you a very convenient, very straightforward way. So you need to install a command. It's called if metric. So you need to run apt install if metric. Yeah, because I already installed it. You can first list the existing route information. Let me say IP route. Okay, you can see there are two default routes, right? At the end, you can see for each route what's the metric, just like what we saw in Windows, right? So you can see for the wired Ethernet connection, the metric is 100. For Wi-Fi, the metric is 600. No wonder the system chooses the Ethernet as the default route, right? Because it has lower metric, so it has higher priority. So we can simply use the if metric command to modify the metric value for each interface. So for example, first, let me change the wireless interface if metric. Let me say change it to 100. For the RJ45, the Ethernet connection, let me change it to, let's say, 1. Then let me run IP route command again. Oh, I'm sorry. The value should be changed the other way. Let me rerun the command. Change the Ethernet connection to, let's say, 1000. then change Wi-Fi connection, let's say to 1. Okay, run IP route. Okay, you can see the Wi-Fi interface has metric 1. Now it has the highest priority. So we can validate it by running traceroute. Traceroute Google. You can see the first hop is through the Wi-Fi connection, through the EFG. So we successfully achieved what we want. By the way, this way won't survive the reboot, which may be a benefit. But if you do want to persist the change, you may use other way. For example, you can modify the etc network interface configuration file. Okay, but for the ways I show you in the video for macOS and Windows, they will both survive the reboot. Okay, this is a short video. Thanks for watching.